Question 14. The circle C1 has equation x squared plus y squared minus 6x plus 14y plus 33 equal to 0. So part A, find the coordinates of the circle center of C1 and then the radius of C1. Okay. So for this one, to find the center and radius, we just have to rewrite into x minus a squared plus y minus b squared equal to r squared form. So let's just do completing the square to rearrange it. So we have x squared plus y squared minus 6x plus 14y plus 33 equal to 0. So I will move all the x terms next to each other and all the y terms next to each other. So now let's do completing the square. So for the first one, that would be x minus 3 squared minus 9. And then the second one, that would be half of 14 is 7. So y plus 7 squared minus 49 plus 33, just plus 33. So then simplify that. We have x minus 3 squared plus y plus 7 squared equal to, so plus 9 and then plus 49 and then minus 33. That would be 25. So that means the center has to be 3, negative 7. And then the radius will be root 25, which is 5. So part A is done. And then part B, a different circle, C2, has center with coordinates negative 6, negative 8, has radius r, where r is a constant. So given that C1 and C2 intersect at 2 distinct points, find the range of possible values of k. Okay, again, for this type of question, it's better to visualize it first. So I'm going to sketch both of these circles. So for the first one is 3, negative 7. We don't have to be that precise. So I'm just saying, so one of them is 3, negative 7. So let's say this one is 3, negative 7. And then the radius is 5. So radius 5 looks something like this. And then the other one, the circle center is negative 6, negative 8. It'll be roughly somewhere like here. So negative 6 and negative 8. And it says, given that C1 and C2 intersect at 2 distinct points. So the smallest possible circle for the second one has to be look like this. So this is when those two circles intersect at only one point. But as long as the circle is bigger than that, for example, the circle slightly bigger, then that would be 2 distinct points. And if it's even bigger, that would be another 2 distinct points. Yeah. Until this circle become this big. So then they only intersect at one point. Yeah. So basically the small circle here, that will be the lowest possible circle. And then this one will be the largest possible circle. And anything between them will intersect at 2 distinct points. So we just have to work out the upper bound and lower bound. So for the distance between 2 centers is very easy to work it out. So the distance between those 2 centers is just square root of negative 6 minus 3 squared, and then plus negative 8 minus negative 7 squared. So if we put that in the calculator, that would be root negative 9 squared plus negative 8 minus negative 7 is negative 1 squared. So that would be root 82. So the distance between those 2 centers is root 82. And then we know the radius of the first circle is 5. So that means the radius for the second one has to be root 82 minus 5. So that would be the smallest possible circle. Yeah. So it has to be bigger than that to make it 2 intersection points, because this one is only 1 section points. So the radius k has to be more than root 82 minus 5 in order to intersect 2 distinct points. And it has to be smaller than whatever the radius for the largest one is. It's not that precise drawing, but so the largest possible circle has to be root 82 plus the radius 5. So then that will be the range of possible values for k. So they want in the set notation form. So it has to be k is more than root 82 minus 5 and then less than root 82 plus 5 inside the bigger curly brackets. Then that'll be the final answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.